Welcome to the Explainer. So, have you ever just sat back, hit play on a 4K Netflix stream, and actually thought about the massive distributed systems architecture making it happen? No buffering, no stutters? Or, how complex data just seamlessly syncs across all your devices the literal second you buy a new phone? Well, the underlying force making all that magic happen is cloud computing. Today, we're unpacking the blueprint to cloud computing fundamentals. Our goal here is to cut through the buzzwords, right? We want to break down the architectural reality and the strategic implications of this absolutely foundational tech. Okay, let's dive into this. Here is our roadmap for today. We've got 5 manageable chunks: demystifying the cloud, everyday cloud examples, types of cloud services, benefits and challenges, and we'll wrap up with cloud careers and the future. All right, section 1, demystifying the cloud, the invisible infrastructure. Let's start with a question to really lock this concept in. Do you build your own power plant just to get electricity at your house? Of course you don't. No way. That would be insanely expensive, highly dangerous, and just wildly inefficient. Instead, you simply flip a switch, tap into the grid generated by the power company, and you only pay for exactly what you consume. And this brilliantly illustrates the core of cloud computing. Historically, companies were basically building their own power plants. They had to buy these massively expensive servers, maintain physical data centers, and constantly upgrade hardware just to keep their heads above water. It was a huge upfront capital expense. But today, the modern cloud approach lets businesses just rent computing power on demand. You shift to an operating expense model where you literally only pay for what you use. This is a total game changer because it frees businesses up to focus on actual product innovation and scaling, rather than just sweating over keeping their server racks cool. Moving right along to Section 2, Everyday Cloud Examples. You're already connected. Let's ground this a bit, because you're actually using this invisible infrastructure every single day. From collaborating with your team on Google Drive or Gmail to firing up Zoom, or even those highly complex streaming architectures running Netflix and Spotify. Heck, even your WhatsApp backups. If your data is seamlessly accessible across different devices, you are actively leveraging the cloud. The processing power and the storage, they aren't sitting on your local device. Your phone or your laptop is essentially just acting as an access node, tapping into a much larger global network. So how does this actually work under the hood? Well, at its core, it's all about shifting the heavy compute load to massive, highly secure remote server farms. Let's say you upload a simple photo to Google Drive. The file travels securely through the internet, fully encrypted, by the way, and it gets stored and processed on redundant remote servers managed by a third-party provider. And because it lives in this huge distributed environment, you can access it anytime from anywhere. Plus, it's heavily protected against localized hardware failure. So if your laptop dies, your data definitely doesn't. Now, you might be wondering, who actually owns all this infrastructure? Well, it's primarily the big 3. First up, Amazon Web Services, or AWS. They are the world's largest provider, mostly because they had this incredible first-mover advantage and just built out a massive ecosystem of specialized tools. Then you've got Microsoft Azure. Azure is incredibly popular among large enterprises because, frankly, it offers really frictionless integration with legacy Microsoft products. And finally, Google Cloud. They often went out with modern tech companies that want to leverage Google's cutting-edge AI and machine learning tools or their high-performance data analytics. Basically, these 3 are acting as the foundational landlords of the modern internet. All right, Section 3, Types of Cloud Services, the Rule of 3. You see, the cloud isn't just one giant monolith. It's an ecosystem broken down into 3 core service models that dictate exactly how much of the underlying tech you want to manage yourself. At the very foundational layer, we have Infrastructure as a Service, or IaaS. This is the absolute bedrock. With IaaS, you are renting the raw, digital building blocks, virtual machines, storage space, and networking. Think of something like AWS EC2. It's essentially like renting a completely empty digital room. This model is absolutely crucial for IT and engineering teams who need complete ground-up control over configuring their specific environment. Let's move to PaaS and see how this builds on that foundation. This middle layer is Platform as a Service, or PaaS. Here, the provider basically steps in and takes over managing the underlying servers, operating systems, and network configurations. You don't have to worry about maintaining or patching that digital room anymore. It comes fully furnished. Providers like Heroku handle all that backend provisioning, which means application developers get to focus solely on what they do best, writing, testing, and deploying their code, without wrestling with the infrastructure at all. And finally, we reach the top layer, software as a service, or SaaS. This is the layer of ultimate abstraction, and it's the one you're probably most familiar with as an end user. Here, you're trading underlying customization for immediate deployment. You aren't coding, you aren't provisioning environments, you are simply using finished, ready-made software directly through a web browser. Tools like Zoom, Canva, or Microsoft 365 fall right here. They're built specifically to deliver value immediately with zero technical overhead for the user. Moving on to Section 4, Benefits and Challenges, Weighing the Reality. Now, what's really interesting about this slide is how it juxtaposes the incredible advantages against some very real practical risks. On the plus side, the benefits are immense. We're talking massive operational cost savings, instant scalability, global accessibility, and automated backups. If your business suddenly goes viral and faces a massive spike in traffic, you can spin up additional servers in seconds and then spin them right back down when the rush is over. But the trade-offs, they are very real. You're introducing an absolute dependency on the internet. If there's an outage, your operations basically halt. You're also dealing with complex security. If even one bucket is mismanaged, it can lead to a huge data breach. And strategically, there's the looming threat of vendor lock-in. Once your entire infrastructure is deeply tied to one provider's proprietary tools, trying to migrate away can become a total logistical and financial nightmare. Finally, Section 5, Cloud Careers and Future, Your Next Steps. Let's pivot to the practical payoff here, because this booming technology translates into some incredibly lucrative future-proof career opportunities. If you're looking to upskill or break into this domain, these are your high-value targets. Roles like cloud architect, DevOps engineer, or site reliability engineer are in massive demand. But to get there, the modern tech stack requires way more than just knowing how to code. You need a solid grasp of Linux and networking, plus certifications in major ecosystems like AWS, Azure, or Google Cloud. On top of that, mastering containerization tools like Docker and Kubernetes, or infrastructure as code platforms like Terraform, that is what will make you an absolutely invaluable asset capable of orchestrating complex deployments. Highly recommend screenshotting this list for later. So the crucial point is that cloud computing is the essential engine driving the next massive wave of technological breakthroughs. Think about it. Resource-heavy innovations simply cannot function without this infrastructure. Whether it's training sophisticated artificial intelligence and machine learning models, processing the absolute petabytes of big data generated every single day, orchestrating the global Internet of Things, or powering massive remote work solutions, none of this exists without the immense, flexible power of the cloud. It literally is the silent backbone of our future. Whether you're an IT pro optimizing a deployment, a developer scaling a new app, or a strategist mapping out a company's technical future, deeply understanding the cloud is absolutely mandatory in today's landscape. So, here's my final question for you. Which cloud computing skill will you dive into first to future-proof your career in the digital world? Are you going to tackle Kubernetes, or maybe start with foundational networking? The infrastructure is out there just waiting for you to build upon it. Thanks so much for joining me on this explainer. Keep learning, stay curious, and I'll see you in the next one.